Google made AI memory 8 times smaller with TurboQuant, a major leap for the future of artificial intelligence. Google researchers have unveiled a breakthrough that could significantly reduce one of the biggest challenges facing modern artificial intelligence: memory usage. The new technology, called TurboQuant, dramatically compresses the memory required by large AI models while maintaining high accuracy. In many cases, it can reduce memory requirements by up to 8 times, making advanced AI models cheaper to run, faster to deploy, and more accessible across everything from cloud servers to laptops and smartphones. As AI models continue to grow into hundreds of billions, or even trillions, of parameters, memory has become one of the industry's biggest bottlenecks. TurboQuant represents an important step towards solving that problem. Why AI needs so much memory? Large language models, LLMs such as Gemini, ChatGPT, Claude, DeepSeek, Llama, and Grok contain billions of parameters that must be stored in memory during inference. The larger the model, more GPU memory is required, higher infrastructure costs, greater electricity consumption, slower deployment, more expensive AI services. Today's leading AI clusters rely on enormous quantities of high-bandwidth memory, HBM, one of the most expensive components inside NVIDIA AI GPUs. Memory, not compute, is increasingly becoming the limiting factor for scaling AI. Enter TurboQuant. TurboQuant is Google's new quantization framework designed to shrink AI models without significantly reducing performance. Quantization works by storing model weights using fewer bits. Instead of traditional 16-bit or 32-bit floating-point numbers, TurboQuant intelligently compresses information into much smaller representations while preserving model quality. Unlike older quantization methods that often sacrificed accuracy, TurboQuant uses advanced optimization techniques to maintain performance while dramatically reducing memory usage. The result: up to 8 times lower memory footprint, faster inference, lower latency, reduced energy consumption, lower cloud operating costs. Why this matters? The AI industry has entered an era where infrastructure costs are exploding. Training frontier AI models already costs hundreds of millions of dollars, while inference costs continue growing as billions of users interact with AI every day. Reducing memory usage directly impacts lower cloud costs. Cloud providers can host more AI models per GPU, dramatically improving hardware utilization. More AI on consumer devices. Efficient models could allow advanced AI assistants to run locally on smartphones, AI, PCs, laptops, tablets, edge devices, without needing massive cloud infrastructure. Faster responses. Smaller models move data through GPU memory more efficiently, improving inference speed and reducing latency. Lower energy consumption. Memory transfers consume significant power inside AI systems. Reducing memory requirements also lowers electricity usage, helping make AI infrastructure more sustainable. A perfect fit for the AI hardware race. TurboQuant arrives as AI hardware companies race to overcome memory limitations. NVIDIA continues investing heavily in larger HBM stacks for its AI accelerators. AMD is expanding its Instinct GPU lineup. Intel is improving its AI accelerators. Google itself is advancing its TPU architecture. Meanwhile, AI startups are developing custom inference chips optimized for quantized models. Instead of simply building larger GPUs, TurboQuant shows that smarter software can unlock substantial efficiency gains from existing hardware. The future of AI PCs. One of the biggest beneficiaries could be AI PCs. Running large language models locally has traditionally required expensive GPUs with large amounts of VRM. With dramatically smaller memory requirements, TurboQuant could enable more capable offline AI assistants, private AI without cloud processing, faster document summarization, local code generation, AI-powered creative applications, real-time translation, enterprise copilots running entirely on device. This aligns with the broader industry trend toward personal AI, where users increasingly run sophisticated models directly on their own hardware rather than relying exclusively on cloud services. Competition is heating up. Google isn't alone in pursuing efficient AI. Across the industry, OpenAI continues optimizing inference efficiency for ChatGPT, Anthropic is improving Claude's performance-to-cost ratio. Meta is releasing increasingly efficient llama models. Microsoft is investing in AI infrastructure optimization for Copilot. DeepSeek has drawn attention with highly efficient open-weight models that challenge the cost structures of larger competitors. TurboQuant adds another powerful tool to this race, demonstrating that algorithmic innovation can be just as impactful as advances in hardware. Industry impact. If widely adopted, TurboQuant could reshape AI economics. Organizations may be able to deploy larger models using existing hardware-reduced GPU infrastructure, spending lower inference costs, serve more users, simultaneously bring advanced AI to edge devices, accelerate enterprise AI adoption. For startups, lower infrastructure costs could reduce the barrier to building AI-powered products. For consumers, it could mean faster, more capable AI experiences on everyday devices. The bigger picture. The future of AI won't be defined solely by ever larger models. It will also depend on making those models more efficient. As the industry pushes toward increasingly capable systems, innovations like TurboQuant highlight the growing importance of software optimization alongside hardware advances. By reducing memory requirements by up to 8-fold while preserving strong performance, Google has demonstrated that meaningful progress in AI can come not only from scaling models up, but also from making them dramatically leaner. If TurboQuant sees broad adoption, it could help accelerate the shift toward more affordable, energy-efficient, and widely accessible AI across cloud infrastructure, enterprise deployments, and personal devices alike.